Transform each of 53 and 54 by making the change of variable I equals k plus 1. So I'm going to give you two formulas that are really the same formulas but expressed in different ways. So on one hand, I equals k plus 1, but on the other hand, k equals I minus 1. And we can get that from the previous equation by subtracting 1 on both sides. But written this way, we have a formula for I and we have a formula for k. So if we're ever wondering what I is, we can use the first formula. And if we're ever wondering what k is, we can use the second formula. So this will add important context when we build our summation here. Now our index variable will be I instead of k. So the first thing we need to figure out is what the lower bound for I is. In the original summation, the index variable k begins at k equals 0. So what would I be if k equals 0? Well, we can use the first equation and plug in 0 in for k to get 0 plus 1, which is 1, equals I. So when k equals 0, that means I equals 1. So the first term of the series corresponding to k equals 0 is the same as the first term of this series corresponding to I equals 1. Now what's the upper bound? Originally, k varies from 0 to 5. So this is really k equals 5. But they don't put the k equals here because the index variable is already implicitly defined here. Well, if k equals 5, then 5 plus 1 is 6, which means I would equal 6 during the last term. Now we can write our expression here. This is k times k minus 1. But we have a formula for k in terms of I. K equals I minus 1. So instead of k times k minus 1, I'm going to write I minus 1 times I minus 1 minus 1. So I'm just substituting I minus 1 in for k. And we could do a little bit of simplification here. We can write this as I minus 1 times I minus 2. And this would be my final answer. Thanks everyone, and I'll see you in the next video.